In this age of generative AI, you would likely heard about the incredible potential of large language models. But as they say, seeing is believing, so get ready to be amazed. In this video, we will showcase the magic of Claude 3, a state-of-the-art foundation model, by diving into real-world demos that demonstrate how it can impact your daily life and work. Hello everyone, I'm Haowen, a senior developer advocate in the AWS Global Developer Experience team. My current focus areas are generative AI, large language models, machine learning, and data science. Let's get started. First, we will take a closer look at the Claude 3 model family. Generative AI isn't a one-size-fits-all solution. Through customers' conversation over the past years, we've identified diverse enterprise use cases. These cases require balance between model intelligence, speed, and quality. But the priority for each case is different. For instance, a chatbot prioritizes low latency over cutting-edge intelligence. Conversely, advanced analytics require superior intelligence, even if it means sacrificing some speed. Therefore, enterprises deploying AI solutions need a flexible range of models to address these diverse needs. Today, I will introduce Anthropic's Claude 3, a new family of state-of-the-art AI models available on Amazon Bedrock. Claude 3 offers three options: Haiku, Sonnet, and Opus. Each caters to specific needs by balance, intelligence, and cost. Developers can choose this perfect combination of these factors to match their business and use case requirement. Claude 3 Opus, occupying the top right position, this is the highest performing model, optimized for maximum intelligence and power. Claude 3 Haiku, located on the left. Haiku is the smallest and most cost-effective model, prioritizing speed and efficiency while retaining significant intelligence. Claude 3 Sonnet, finding in the middle ground. Sonnet strikes a perfect balance between cost, speed, and intelligence, making it ideal for a wide range of business applications. Claude Opus shines across various evaluation benchmarks, outperforming competitors in expert knowledge, reasoning at various education levels, multilingual competence, and even math and coding. For deep dive into the specific numbers and benchmarks, please refer to the link in description. One key feature I want to highlight here is the addition of vision capabilities across all Claude 3 models. These capabilities allows Claude 3 to understand visual content, such as charts, graphics, technical diagrams, and reports. Notably, it achieves this processing speed even faster than some specialized multimodal models, while still maintaining its high performance. Now, let's see Claude 3 in action. We will explore 5 impressive applications built using Claude 3 on Amazon Bedrock. 4 will leverage the interactive interface within the AWS console, while the final demo will showcase the power of Bedrock's API by directly calling the Claude 3 model. Let's kick things off with the first demo, circuit defect detection in an industrial setting. This powerful demo showcases how Claude 3 running on Emerald Bedrock can identify defects on circuit boards, as you will see on this slide. The left image illustrates common circuit board defects. The middle image shows a normal, defect-free circuit board, and the right image displays a circuit board with various defects. In the following demo, you will see me using this prompt to query the Claude 3 Sonnet model. As a prompt here, given the role of a professional circuit board design engineer, analyze the attached images for defects. Here is a breakdown of the task. Number 1, for image 1, identify and describe the types and the specific example of defects present. And number 2, for image 2 and 3, determine if there are any flaws in these circuit boards. If so, pinpoint the specific defects in each image. Let's introduce the images and the text that will serve as a prompt for the model. These images, as described earlier, are image number 1 illustrates common defects found on circuit boards. Image number 2 shows a normal circuit board. And image number 3 displays a circuit board with defects. The text below is the text portion of the input prompt, which we've already covered in detail on the previous slide. Next, let's explore the interactive way of Emerald Bedrock. You can easily access Emerald Bedrock by searching for Bedrock in the AWS console search bar. After clicking Get Started, click Chat on the Playgrounds in the left-hand menu. This will display a Chat Playground dialog interface on the right. Click Select Model, then Orthorhombic, and select the Claude 3 Sonnet model. We will use this in this demo. Finally, click Apply to enter the Claude 3 Sonnet Chat Playground dialog interface. Now, we can input our combined image and text prompt. Let's start by uploading the 3 circuit board images we discussed earlier. First image, second image, and third image. Next, we will copy the text portion of the prompt from the notepad and paste it into the dialog box. Finally, click Run to submit the entire prompt to the Claude 3 Sonnet model. Now, we await the Claude 3 Sonnet model's output. In next demo, we will use the same prompts for both Claude 3 Sonnet and Claude 3 Haiku, comparing their response speed and output result. The Claude 3 now is outputting the results now. We could see from the output that the Claude 3 correctly identified that image number 1 shows different types of defects commonly found on PCBs. And image number 2 depicts a circuit board without any obvious defects or flaws. And image number 3 appears to be potential defect or flaws, highlighted with a green arrow. This screenshot captures the output from the Claude 3 Sonnet model in our first demo. What are your thoughts? Claude 3 Sonnet's ability to identify defects quickly is impressive. This demonstrates Claude 3's potential for applications requiring multimodal capabilities, aligning with our earlier discussion. In the first demo, we only tested the Claude 3 Sonnet, which took about 10 seconds to generate an output. You may also want to test another Claude 3 model, Haiku, and compare the accuracy and speed of the two models in completing the task. The good news is that Bedrock provides a shortcut function that helps developers easily complete such comparison tasks. This is the content of our second demo. Similar to the first demo, we will pit two Claude 3 models against each other for the same circuit board defect detection task. First, we will select the orthorhombic Sonnet model displayed on the left side of the chat playground. Then, click the Compare Mode button in the top right corner and choose the Haiku model. This will display both models side by side in the interface. Next, we will enter the prompts in the dialog box. Finally, click the Run will initiate both models to work on the task simultaneously. Next, upload the same three circuit board images we used in the first demo, and copy the same text prompts we have prepared. Then, click Run to submit these image and text prompt combinations. As seen from the comparison of the outputs of the two models, the Haiku model completes the task in just 7 seconds, while the Sonnet still took about 10 seconds. The Haiku model seems to be faster than the Sonnet model. But what about accuracy? Taking a closer look at the output of Haiku model, you can see that the Haiku model didn't detect the flaw in the circuit board in image number 3, while the Sonnet, although it took longer, successfully detected the flaw in the circuit board in image number 3 again. It seems that in the complex scenario of circuit board detection, Sonnet model's ability to solve real problems is still better. This demo effectively highlights the trade-off between speed and the accuracy observed in the model comparison. A key takeaway is the convenience of Bedrock's Compare Mode feature. With just a single switch, developers can easily compare outputs from different models. Demo number 3 showcases the Claude 3 model working as a coding advisor. In this scenario, we assumed that you are a beginner in the field of machine learning. After reading many books and documentation, you are curious to try to write a complete convolutional neural network from scratch to deepen your learning and understanding. Demo 3 is designed for this scenario. We will use the prompt words shown in this slide. Please implement a convolutional neural network from scratch using Python. Finally, gave an example of how to use the implemented CNN and sample values as input to predict the output of the model. Since these codes are for beginners, please try to meet the following conditions. Number 1. Provide detailed code comments. Number 2. Draw a structural diagram of the layers of the convolutional neural network you designed. Now let's demonstrate the scenario of Claude 3 as a coding advisor. First, we choose the Sonnet model. After clicking Apply, we will come to the Bedrock chat playground again. Since the model's output for this task might be very long, navigate to the Configurations area on the right and set the length parameter to its maximum value, such as 4096. This will ensure we capture the complete output. Next, we copy the prompts we introduced earlier into the input dialog box. Please implement a convolutional neural network from scratch using Python. Finally, giving an example of how to use the implemented CNN and sample value as input to predict the output of the model. And since these codes are for beginners, please try to meet the following conditions, like that. After clicking Run, Claude 3 will generate the answer to the coding question. The answer will then be displayed in the chat window. We can see that the Sonnet model is very fast. This time, it starts to output the result in about 2 seconds. From the code the Sonnet model is currently outputting, it seems to trying to implement a convolutional neural network with comments. It defines functions for ReLU activation, convolution, max pooling, and fully connected layers. The sample code demonstrates processing a 4x4 grayscale image and shows the outputs at each step. A diagram further illustrates the CNN structure with these layers. Here, Claude 3's output has impressively drawn the structure diagram for each layer of the convolutional neural network it designed, following our prompt words perfectly. Very intuitive and clear, right? Real-world CNNs typically have more complex architectures. However, I think the demo code generated by Claude 3 is a good code example for machine learning beginners. After completing this demo, adventurous developers like you might be curious about the code generated by Claude 3. Can this code actually run and implement a convolutional neural network? My experience shows that it's basically possible. While the first generated code has some bugs, through continuous communication with Claude 3, we were able to achieve a complete and correct code. I will show some of the full code generated by Claude 3 in the fourth demo. Demo number 4 showcases writing a tech blog post with Claude 3 on Bedrock. Building on the complete code generated by Claude 3's Sonnet model in demo number 3, we will test its ability to write a tech blog post using the following prompts. Here are 2 prompts planned to use. Prompt number 1, let's craft a tech blog in around 500 words based on the insight we can glean from this code snip. Prompt number 2. I'm not satisfied with your blog post. It's too simple. Please revise it. Now let's move on to the fourth demo, which is about having a large language model write a tech blog post. The text on the left is the code generated by the Claude 3 model in demo number 3. To make it easier to see, I converted the code to the Jupyter notebook on the right. My Jupyter notebook is running on an Amazon SageMaker notebook instance. You can also run a Jupyter notebook locally using a programming tool such as Visual Studio Code. Next, we need to select a working model and input prompts. We will still choose the Claude 3 Sonnet model and then input the first prompt that we prepared earlier into the dialog box. Let's craft a tech blog post in around 500 words based on the insights we can glean from these code snippets. We will also input the complete code output by the model in demo number 3 as part of the prompt into the dialog box. And click Run. We can see that the Claude 3 model is quickly generating a tech blog post based on our first prompt and the code. The title of the article it outputs is Understanding Basic Building Blockers of Convolutional Neural Network. If you are not satisfied with the blog post that it outputs, you can input your new prompt in the dialog box and let it continue to modify it. For example, I'm not satisfied with your blog post. It's too simple. Please revise it. After clicking Run, the Claude 3 model quickly generated a new tech blog post. Because you said that the previous one was too simple, this time, the tech blog post it generated is more in-depth, as can be seen from the new title of the article, as follows. Demystifying Convolutional Neural Networks, a deep dive. Screenshot of this slide shows the whole process of how we let Claude 3 model help us write technical bloggers in this presentation. I hope it will be inspiring to you, as you may have already found. Whether you like it or not, large models have already started to affect the way we work. Let's embrace large models wholeheartedly and let them help us work more effectively. The first 4 demos showcases the capabilities of the Claude 3 model using the AWS Bedrock console. However, the Bedrock API offers an alternative approach. The Orthorhombic official website provides a remarkably intuitive way to access the Claude 3 model via the Bedrock API. Their 10-line code example demonstrates how to use Claude 3 with Bedrock APIs. In this slide, I leveraged this very same 10-line code snippet to implement the Claude 3 model. This enables it to write a 300 words novel in the style of Shakespeare. Relying on the Bedrock API offers a more objective way to acquire results for interacting with the Claude 3 model, compared to the playground mode within the AWS console. Consider demo number 2, where we compare the perceived response speed of Claude 3 models, Sonnet and Haiku. While Haiku seemed faster, this approach lacks objectivity. The Bedrock API offers a solution. By calling the Claude 3 models through the API, we can compare key metrics like invocation latency and first byte latency, as shown on this slide, to quantify the actual speed difference. To see the full code for this example, you can check out the repo link in the description. Let's recap. Today, we will explore the Claude 3 family of models available on Amazon Bedrock. These models achieve a perfect balance between intelligence, speed, and cost, making them a versatile solution for a wide range of enterprise applications. We witnessed some impressive demos showcase Claude 3's capabilities, including detecting circuit board defects, contrasting model outputs to cater to diverse industry needs, generating Python code to implement a sample of convolutional neural network, composing technical blog posts based on the generated code. We also introduced 2 code samples demonstrating how to use Claude 3 with Amazon Bedrock APIs. Its ability to understand and process various modalities of data, generate code, and tailor outputs to specific prompts truly sets Claude 3 apart. These features have the potential to revolutionize AI-powered applications across numerous industries. Awesome! That covers everything for today. The field of large language models is rapidly evolving, and I will keep you updated on the latest breakthroughs over on my LinkedIn page. You can find the link in the description. Thanks so much for watching. If you enjoyed this video, be sure to like this video and subscribe to the AWS Developers YouTube channel. I look forward to connecting with you again next time.